Hello students, welcome to Sri Jayendra's Rank Zone classes. I am your friend and mentor for coming classes with respect to physics. This is lecture number 12 of a unit system of particles and rotational motion. So let's begin with today's class. In today's session we are going to discuss about the additional questions on rotational motion. This is part 2 of the additional questions of rotational motion. So let's begin with today's class. The question says that a thin rod of length L can rotate in vertical plane about horizontal axis, that is passing through the one end of the rod without friction. It says the rod is released when it is in horizontal. The initial angular acceleration of the rod. So first let's have the situation that how it could look like. This is the initial situation. Initially this is the road and it can rotate in the vertical. It has been hinged from the end point. It says that about an horizontal axis passing through the one end of the road without friction. Yes, so this is having mass m, length L. The road is released when it is horizontal, the initial angular acceleration of the road. So what I understand is that this is the midpoint, and if this is the midpoint, from here it's an mg that is acting. This distance is the L by 2. So what I understand is I need an angular acceleration, and when I need an angular acceleration I would always look for the torque. So what I can do is it's a torque that should be is equals to I into alpha. Now in this case who will provide me the torque? I understand that this is the mg who will provide me the torque. So this could be written as mg multiplied by L by 2, that is equals to I. I is the moment of inertia and it has been rotated from the end part. So if it has been rotated from the end part, that could be written as ml square by 3 multiplied by alpha. I hope this is clear. So this m, this m has been gone, this is gone, and alpha, that is equals to 3g by 2l. This is the answer. Alpha is equals to 3g by 2l. I hope this is clear. Got this? Have you got this? Are you sure? Can you do this? Can you? Is it possible? Great. Let's work for the next question. The next question says that a flywheel of moment of inertia this 0.4 kg meter square is free to rotate in vertical plane about horizontal axis, passing through its center without friction. It says an external torque of 10 Newton into meter is acting on the flywheel, which is initially stationary. Yes. Now the angular velocity of the flywheel, when it completes 100 divided by pi rotations. These are the rotations. These are the revolutions. So how will you do this, or what could be done? What I understand is that it is something like this. It could be that this was the flywheel, this was its center, and from here a force has been given, and due to this force into r, a torque has been applied on this, and this torque, it's a 10 Newton into meter. What all other data is given? Let's see that a moment of inertia of this flywheel is given. It's an I which is equals to 0.4 kg meter square is given, and what else? Yes, so I is given, torque is given, and when it completes 100 by pi rotations, so this theta is equals to 100 by pi. This is one, if one rotation it's a 2 pi, so it's 100 by pi into 2 pi. This is equals to 200 radian. What do you require? You require the angular velocity, that means omega is required. So this is all that is given, and omega is required. How will you do this? How will you do this? How could I? Yes. So what I understand is I am having an option that torque equals to I into alpha, and the torque is given that is equals to 10 Newton into meter. The moment of inertia is given, it's a zero point 0.4, that means it's a 4 by 10 multiplied by alpha. So alpha should be equals to 10 into 10 100 by 4, which should be 25 radian per second square. Now I am having an alpha. Even I am given that it was initially at rest, initially stationary. That means omega not equals to 0 is given. So I need to find out omega. So that could be done. That could be done by the relation which is omega square minus omega naught square is equals to 2 into alpha into theta. The final velocity is required. This initially it is 0. This is 2 multiplied by alpha, which is equals to 25. And the theta, what was it? Yes, theta. What was it? The theta was, yes, it is a 200 radian. So this is equals to multiplied by 200. So this is 25, 2s are 50 into 200. This is omega square. This is the omega square. I hope this is clear. Is it clear? Is it clear? Yes. So this is omega square, which should be equals to 5 2s are 10 into 0 0 0. It's a 10 into 10 to the power 3, which is 10 to the power 4. So omega is equals to 10 square, which is equals to 100 radian per second. I hope this is clear. Does it clear? Does it? So can you do this? Yes, it is easier. Always look for the torque when alpha is required. When alpha is required, always look for the torque, and that is sure going to help you guys. I hope this is clear. Is it clear? Great. Now let's look for the next question. This question says that if the radius of the earth shrinks by 25 percentage, if the radius of the earth shrinks by 25 percentage without change in its mass, the time duration of 1 day will be. How will you do this? So they say that the radius has been shrink, and while radius has been shrink, what I understand is that this situation in this situation no external torque is acting on the system, and if external torque equals to 0, that means initial angular momentum should be equals to final angular momentum. I hope this is clear. So initial angular momentum and final angular momentum would be the same. If I continue with this, it's an Li is equals to Lf. Li, it's an I1 omega 1, that should be is equals to I2 omega 2. They are talking about the earth, that I need to consider it as a sphere, that could be written as 2 by 5. It's an m into r1 square multiplied by omega 1, that is 2 pi by t1. That should be is equals to 2 by 5 into m into r2 square multiplied by 2 pi by t2. So let's just solve this. And get it done. So this could be 2 by 5, 2 by 5 has cancelled, m has cancelled, 2 pi has cancelled. So only I have been left with the r1 square by t1, that should be is equals to r2 square by t2. While doing this, initially let's understood that initially radius was 100 divide by, and now in this situation time period is 24 hours. Now it has been reduced by 25 percentage, then the new radius will be equals to 75 square divide by t2. So is it clear? Is it? So t2 will be equals to, t2 would be equals to 75 into 75 into 24 divide by 100 into 100. This is 25 3s are, this is 25 4s are, this is 25 3s are, this is 25 4s are, this is 4 6 are 24. So this is 3 threes are 996. 3 threes are 996 are 54 by 4. And 54 by 4 could be 13 fours are 15 2. Yes, 13.5 hours. So only the time period of the earth would be 13.5 hours. So within this 13.5 hours you will be having a complete day, which is at present it's a 24 hours. I hope this is clear. Is it? Is it? Great. So can you do this? Can it be done? Can it be? Great. Let's work for the next question. The question says that L is the angular momentum of an electron which is revolving around the nucleus of H atom in the first orbit of radius r. Okay. The angular momentum of the same electron when it is revolving in a bigger orbit of radius 9r. So how will I do this? How could I? How could I do this? Let's have a look. We understand that we understand that L is equals to n into h by 2 pi. This is according to the second postulate of Bohr. It's an angular momentum is equals to integral multiple of h by 2 pi. So what I understand else is that L is directly proportional to the n, and this r is directly proportional to the n square. So according to this L is directly proportional to the root of r. From this we can have it's an L1 by L2 is equals to R1 by R2 to the power 1 by 2. So initially first radius was r, and then the radius was 9r. So this is r by 9r to the power 1 by 2. This is equals to 1/3. So from this L2 is equals to 3L1, and L1 was L, so I could write it's an L2 is equals to 3L. Please keep this in mind. This is very good question because it mix up the concepts of physics and chemistry. Yes, these are the multiple conceptual questions. Very good questions. Let's work for the next question. It says that a ballet dancer is rotating about her own axis at the rate of 1.6 rotations per second. Great. On smooth horizontal floor. On folding herself close to the axis of rotation, her radius of gyration decreases by 20 percentage. Then find out then final frequency of rotation. Again, this is the case of the conservation of of angular momentum. This is the case of conservation of angular momentum. While I say momentum will be conserved, I understand that initial angular momentum would be equals to final angular momentum. Now in this case the situation is they have given the rotations, given the rotations per second, and they were talking about the radius of gyration. So how will I do this? How will I do this? What I understand is that L is equals to I omega. Li is equals to Lf. So this is I1 omega 1. That should be is equals to I2 omega 2. While I write I1, it's an m into k1 square multiplied by omega 1. It's a 2 pi into frequency 1. This is equals to m into k2 square into 2 pi into f2. So this m is gone. 2 pi has gone. So this is equals to k1 square into f1. That is equals to k2 square into f2. So initially let's took this as an 100 square multiplied by frequency. The frequency was given at 1.6 rotations per second. Yes, it's a 1.6 rotations per second, so this is 1.6. Finally what I want, yes, the final frequency of the rotations, while radius of gyration has been decreased, so I have been left with the 80 square multiplied by f2. So this f2 would be equals to 100 square multiplied by 1.6 divided by 80 square. So this could be written as F2 is equals to 100 into 100 into 1.6, 16 by 10 divided by 80 into 80. Yes, 0 0 0 0, this 0, this 0. And this is 10 into 16, which is 160, divide by 8, 8 into 8, it is a 64, which is 2.5, 2.5 rotations per second. I hope this is clear. Is it? Is it clear? Are you sure? Are you? So, so this all are the questions. This all are the questions which are very, very good, very conceptual questions. I hope you can do this. Great. Next, again same question, but have a certain different aspect of the question. If radius of the Earth shrinks, if the radius of the Earth shrinks by 0.1 percentage without change in its mass, the percentage change in the duration of one day. So what now we understand is Li is equals to Lf, and if I write this Li is equals to Lf, what I understand is that I will write I1 omega 1, that is equals to I2 omega 2. If I write like this, it's a 2 by 5 m1 r1 square multiplied by 2 pi by t1, that is equals to 2 by 5 m1, because mass is not going to change, into r2 square into 2 pi by t1. So while doing this, it's a this is this 2 by 5, 2 by 5 has been cancelled, mass is cancelled, 2 pi is going to cancel. So that means it's an r1 square by t1, that should be is equals to r2 square by t2. I hope this is clear. So what I can understand is that r square is directly proportional to the t. Yes, and if I can write this, it's an r square directly proportional to the t, because the shrink of the earth is just by 0.1 percentage, and this is within the limit of an error. So if it is within a limit of an error, what I can write, it's a 2 delta r by r, that should be is equals to delta t by t. As they said that radius has been changed by 0.1 percentage, so this is equals to 2 into 0.1, that is equals to delta t by t. So delta t by t, that is equals to 2 into zero point 0.1, it's a zero point 0.2. Yes, this is the variation. One more thing, as you can see, this two are in the directly proportional, and as they are in the directly proportional with each other, it is, as this is earth shrinks, that means it is going to decrease, that means even the time period is going to decreases by 0.2 percentage. I hope this is clear. Is it clear? Is it? Does it clear? Are you sure? Great. Let's move for the next question. You are doing good job. Well done. Make it quick. The question says two circular disks of moment of inertia 0.2 kg meter square and 0.3 kg meter square are rotating about their own axis at the rate of 200 rpm and 100 rpm, both in clockwise order. Yes, if both are gently brought into contact to rotate about the same axis, the angular velocity of the combination. So what you want to do is that both are initially rotating in the same manner. They say that in the clockwise order. Now what you want them to move across the same rotational axis, and you want the angular velocity of the combination. So if this is the situation, what I can write, it's an initial angular momentum should be equals to final angular momentum. Initially they both were moving. This is initial angular momentum, this is final angular momentum. They both were moving in the same fashion. So this could be written as I1 omega 1 plus I2 omega 2. and finally they will be having a combined velocity, so that could be written as I1 plus I2 into omega. While writing this I can have the first one, it's a moment of inertia of zero point 0.2. The first one, it's a 200. Second one, it's a moment of inertia of zero point 0.3, and omega 2, it's a 100. Would be equals to zero point 0.2 plus zero point 0.3 into omega. So this could be written as, that could be omega is equals to 70 divided by zero point 0.5, which is 140 rpm. Have you got this? Have you? So do you understand this? Do you? Are you sure? Any doubts up till now? Is there anything? Is there? Is there anything? No? Are you sure? Are you? Great. Let's work for the next question. The next question says that a circular disc is rotating in horizontal plane about vertical axis, which is passing through center of disk without friction with a time period of zero point 0.2 seconds. If another identical circular disc is gently placed symmetrically on a rotating disk, the time period of the combination of the two disks is. So how will you do this? How will you do this? It says that one of the disk was there and it was already rotating, and the time period of that disk was the zero point 0.2 seconds. Now if another identical, that means their moment of inertia would be the same. There another identical disk has been placed. What would be the time period of the combination? How could I do this? So what I understand is this Li is equals to Lf. Initially only one of the disk was rotating, so it's an I1 omega 1. Then it was two disks that has been rotating. So what I could write, it's an I1 plus I2 multiplied by their omega. So this is I1 multiplied by omega 1, which could be written as 2 pi by T1. As they said identical, so I could write it's a 2I1 divide by T2. I hope this is clear. So this has gone, and this sorry, this 2 pi has gone. So that could be written as T2 should be equals to 2 into T1. It will take twice of time as compared to the previous one. This is equals to 2 into zero point 0.2, which is equals to 0.4 second. I hope this is clear. Is it clear? Is it? So can you do this? Can you? Are you sure? Are you sure? Can you do this? Can it be done? Can it be? Are you sure? Great. Let's look at this question. The question says that a metallic circular plate is rotating about its axis without having any friction. If the radius of the plates expanded by 0.1 percentage, then the percentage change in its moment of inertia. Okay, so a circular plate is there and it is rotating about its axis without having any friction, and we are going to increase the radius of the plate. So what I know is that moment of inertia I for a circular plate, it's an I is equals to mr square by 2. What I'm going to change is the radius, so I can write it's an I directly proportional to the r square. If I can write this, I am having this relation I directly proportional to the r square, as this change is within the limit of an error. So I can use the relation of the errors. It's a delta I by I equals to twice of delta r by r. I'm going to change this delta r by r by 0.1 percentage, so delta I by I, that is equals to 2 into zero point 0.1, which is 0.2 percentage. Yes, one more thing, the radius and moment of inertia both are directly proportional to each other. So It means that if radius is increasing, because it expands, radius is increasing, even moment of inertia is going to increase. It will increases by 0.2 percentage. I hope this is clear. Is it clear? Is it? Great. Let's work for the next question. Do it quickly. It says that a circular plate is rotating in horizontal plane without friction about its own axis with a time period of 0.1 second. Now, another identical circular plate is gently placed on the first plate such that a combination of two plates become a thick circular plate. And what I want the angular velocity of this thick plate. That means I want the angular velocity of this combined system. How will you do this? How could we do this? Yes, first the situation is that initially this circular plate was there and it is already in rotation. I'm going to put another identical plate, something like this, that one more plate is going to be placed over this. And if now this will both are moving with new angular velocity, that is what I required. So what I can do is that according to the conservation of angular momentum, according to the conservation of angular momentum, what I can have, it's an I1 omega 1, that should be is equals to I2 omega 2. I hope this is clear. Now a time period of first plate has been given, and I want the angular velocity omega of thick plate of the combined system. Yes, so it's an I1 omega 1 is equals to I1 plus I2 into omega dash. So this is I1 multiplied by 2 pi by T1, that is equals to, I know that it is, that has been written as an identical plate, so this could be written as 2I dash into omega dash. This is what required. It's an I1 multiplied by 2 pi divided by T1. T1 was the 0.1 seconds, that is equals to 2I1. This I1 could be cancelled out into omega dash. This 2 can cancel out, so omega dash is equals to pi divided by 0.1. It's a 1 by 10. So this omega that should be is equals to 10 pi radian per second. This is what the required, the angular velocity, what the angular velocity is required. So that would be the omega, that is equals to 10 pi radian per second. But according to the options given, they required it in rotations per minute, and whatever the answer we have received, that is equals to 10 pi radian per second. So I need to convert it to the radian per second to rotation per meter. I hope you can do this. Yes, so rest of the task, will you capable to do this? Will you be? How can I convert radian per second to rotation, sorry, revolutions per minute? So when I need to convert revolutions per minute to radian per second, I just I just convert I just multiply RPM by 2 pi by 60, so that I get the radian per second. So here it's a radian per second multiplied by 60 by 2 pi will give me a revolutions per minute. So this omega dash could be written as it's a 10 pi multiplied by 60 divided by 2 pi. This is 2 pi into 5. This is 300 RPM. I hope you got this. Yes, this is the correct answer. What was your answer? Was it same? Was it? Great. So ready for the next question? Are you ready? let's have a look then. It says that a ballet dancer is rotating about his own vertical axis on a smooth horizontal floor with a time period of 0.5 seconds. The dancer folds himself close to his radius of gyration that decreases by 20 percentage. Then the time period is, yes. So what is going to change? He or she is going to change the radius of gyration by the 20 percentage. Yes, and what I want to find out time period. How will I do this? How can we do this? If I understand, this is the question that we have done same kind of question in the previous as well. Yes. So what I can do is that initial angular momentum is equals to final angular momentum. This could be written as I1 omega 1 is equals to I2 omega 2. Moment of inertia I can write it's an m k1 square multiplied by time period is given, so replace this by t pi by t1, that is equals to m into k2 square multiplied by 2 pi divided by t2. This 2 pi has been gone, m has gone, 2 pi has gone, so I have been left with the k1 square by t1 is equals to k2 square divided by t2. Yes, now you have everything. You have t1 which is equals to 0.5 second. You want to find out the t2. K1, it's the initial radius of gyration. Take it as an 100, and new radius of gyration that has been, it is going to be decreased by 20 percentage, so it would be an 80. Put up the value and get the answer done. I hope this is clear. So will you capable to do this? Are you? Are you serious? Great. Well done. Let's work for the next question quickly. The next question says that a bullet of mass 50 gram is projected upward with an initial velocity of 200 meter per second in a direction of angular projection 60 degree. Okay, the angular momentum of the bullet, when it is crossing the highest point with respect to the point of projection. Okay, so what they want is that, let's say this is x, this is y, and the object has been launched something like this, that this is the initial velocity u, this is the angle theta. So when this bullet will reach the maximum height, it would be at this point. What I want the angular momentum. I want the angular momentum with respect to origin. So at this position, angular momentum could be written as, this is the momentum vector, and that momentum vector will be equals to m into u into cos theta. While I write this, that this is the angular momentum that could be given as m into u into cos theta, I want the angular momentum. So what I'm supposed to do is that let's shift this vector over here. I hope this is clear. I'm going to shift this vector over here. So this is the perpendicular distance, and that is the h max for me. So angular momentum L could be written as m into u cos theta multiplied by h max. This will give me the angular momentum with respect to origin. Have you got this? Yes. So let's have a look. I have done the same thing. I have written it over here. It's an angular momentum that would be equals to m into v into h, and and if I replace the value of h max, that was equals to u square sine square theta divide by 2g. So it's a u square sine square theta by 2g. This v has been replaced by u cos theta, and if I put up the value and get the answer, it's a 7.5 into 10 to the power 3. Yes, take your time, have it on a calculation basis. Yes, but I hope this can be done. Can it be done? Can it be? Can it be done? Are you sure? Shall I add something to this? Shall I add something to this question? May I? Let's have a look. It says that in the previous question, find out angular momentum of bullet with respect to origin when bullet just about to complete the journey. Yes, this is required. Please do it. Such as this was, we can now understand that this was the location 1. This was the location number 2 where you require the angular momentum. I hope you can do this. Yes, if not, we have already done this. We have already done this in the lecture of conservation, angular momentum and their conservation. If you don't have an idea, go through it, revise angular momentum session one more time, and back with this numerical. Great. So now let's work for the next question. It says that if the total kinetic energy of a rolling solid cylinder is 24 joule, then its rotational kinetic energy is, okay, how will you do this? What can we do? So what I understand is that kinetic energy total would be equals to half mv square into bracket 1 plus k square by r square. This total kinetic energy is 24 joule, that is equals to half mv square into bracket cylinder. When I say it's a cylinder, it's a k square by r square, it's a half, it's a 1 plus 1 by 2. So this is 24 is equals to half mv square into bracket 1 plus 1 by 2. That could be written as 3 by 2. So this is half mv square is equals to 24 into 2 divided by 3. It's a 16 joule. But this is translatory kinetic energy. This is translatory kinetic energy. So when I understand the total kinetic energy, it's a total kinetic energy. It's a rotational translatory kinetic energy plus rotational kinetic energy. Yes, total kinetic energy is 24. Translatory kinetic energy is 16. So this is remaining part, and that x would be equals to 8 joule. That we understand. This was the answer. I hope this is clear. Is it? Can you do this? Can you? Are you sure? Can this be done? Can it be? Great. Let's work for the next question. It says a thin metal disc of radius 25 centimeter and mass 2 kg starts from rest and rolls down on an inclined plane. If its rotational kinetic energy is 8 joule at the foot of the inclined plane, then the linear velocity of the center of mass of the disc. How will you do this? How will we? How could I? Yes, what can be done? They are talking about the rotational kinetic energy. It is at the 8 joule at the foot of the inclined plane. The situation would be something like this. It has started from here and ended up on here. Yes, metal disc of radius is given, that is of 25 centimeter. Mass is given, that is of 2 kg. It starts from rest, so u equals to 0. Rolls down on an inclined plane, and if it's at here, at this position, it's having kinetic energy which is equals to 8 joule. So what I want the linear velocity of the center of mass of the disk. How will I do this? How? So what I understood it, it's a kinetic energy is equals to again half mv square into bracket 1 plus k square by r square. So the kinetic energy, it's a 8 joule. This is equals to 1 by 2 multiplied by mass, that is of 2. It's a velocity. Let's find it out. It's a 1 plus k square by r square. It's a thin metal disc. When it's a thin metal disc for the k square by r square, it's a 1 by 2. So this 2 has gone. This 8 is equals to v square into bracket 1 plus half. This is equals to 3 by 2. So this v square could be written as this v square. One second. They said that if it's a rotational kinetic energy, I need to change this. They are talking about the rotational kinetic energy. So this is the total kinetic energy. To write down the rotational kinetic energy, give me the moment. Yes. So the kinetic energy of rotational motion could be written as half I omega square. This is equals to half into mk square into omega square. Omega, it's a v square by r square. Now it's an 8 joule. This is 8 is equals to half into mass, it's a 2 k square by r square. For disk it's a 1 by 2 into v square. This has gone. This v square equals to 16, so this v would be equals to 4 meter per second. That's it, you did it. Great job, well done. Ready for the next question? Ready? Let's have a look. This question says that a solid cylinder at rest at the top of an inclined plane of height 2.7 meter rolls down without slipping. If the same cylinder has to slide down a frictionless inclined plane, the same cylinder has to slide down a frictionless and acquires the same velocity as the acquired by the center of mass of the rolling cylinder at the bottom of the inclined plane, the height of the inclined plane in meter should be. How will you do this? So the situation is that initially a solid cylinder is at rest at the top of an inclined plane of height 2.7 meters. So let's have a sketch of it. First, it's a cylinder, and solid cylinder is that it is it has started its journey from the rest and rolls down without slipping. It is going to rolling. If the same cylinder, if the same cylinder and this height is given, even this h is equals to 2.7, if the same cylinder has to slide down a frictionless, okay, so that means this is with friction, then only it can roll. Now the second wage is 1 without having any friction, and cylinder will be the same, has seems to slide down a frictionless and acquire the same velocity as that acquired by the center of mass, the rolling cylinder at the bottom of the inclined plane. Okay, so what I want, the height of the inclined plane in meter. This is required. How will you do this? How could we do this? So what I understand is that this is h, and this change in potential energy would be converted to the kinetic energy. Yes, yes, yes. So how can I do this? It's an mgh. It's a rotational kinetic energy. It's a half mv square into bracket 1 plus k square by r square. While I'm writing, it's in half mv square 1 plus k square by r square. This k square by r square, it's a 1 plus half. So this is equals to half into mv square into 1 plus half. It's a 3 by 2. That is equals to 1 by 2 multiplied by 3 by 2 multiplied by mv square. This is equals to mgh. So this m and this m has gone. So this g into h is equals to 3 by 4 into v square. Yes. So let's get the data filled. G is 10. H is, this h is 2.7. This is equals to 3 by 4 into v square. So this is 3 into 2.7, it's a point of 9. And v square it's a 36, which will give me a v is equals to 6 meter per second. This is just the velocity. Now what I need to do is on this there is no friction is there. And when there is no friction, this velocity will be equals to root of 2gh itself. They said the velocity would be the same. So now it's a v is equals to root of 2gh. So this v square equals to 36. It's a 2 into 10 into h dash. So this h dash would be equals to 36 by 20. It's a 1.8 meter. I hope this is clear. Does it? Very good question. I hope this is clear. Is it clear? Is it? So ready for the next question? Are you ready? Let's have a look. It says that the rotational kinetic energy of a body, it's an AT-joule. If the moment of inertia of the body about the axis of rotation is this 4 into 10 to the power 7, the angular momentum, okay, great. So if you understand that we have this relation when we used to have a linear momentum, it's a kinetic energy that could be written as p square by 2m. Yes, p is the momentum, it's a linear momentum, and m is the mass of the body, and this is the kinetic energy. Same way here I could have, it's a kinetic energy which should be equals to L square by 2L, while L is the angular momentum and I is the moment of inertia, that you understand. So let's just put the value and get it done. It's a kinetic energy is equals to L square by 2y. The kinetic energy, this is equals to 80 is given. Angular momentum is required, L square divided by 2 into moment of inertia. This moment of inertia, it's a 4 into 10 to the power 7. So this L square is equals to 80 into 2 into 4 into 10 to the power 7. So this will be equals to the, it's a 2 8 into 10 into 2 fours are again 8 into 10 to the power 7. So this is 8 square into 10 to the power 8. This is L square. So this L is equals to 8 into 10 to the power 4. Yes. It's a rotational kinetic energy of a body. So this is the angular momentum. It's an 8 square into 10 to the power 8. This is 8 into 10 to the power 4. Yes, there is a correction over here. Yes, this option needs to be changed, but this would be the answer. It is the angular momentum. It is the angular momentum. I hope this is clear. Is it? Is it clear? Are you sure? Are you? Great. Let's work for the next question. The next question say it's a rotational kinetic energies of two flywheels are equal. They were talking about the rotational kinetic energies. If the ratio of their moment of inertia is 1 is to 4, then the ratio of their respective angular momentum. Yes, again we are doing the same thing. It's a kinetic energy which is equals to L square by 2I. They said that rotational kinetic energies are equal and their moment of inertia has been given. So it's an L square directly proportional to the I. So you can write this, it's an L2 square, or let's write it a ratio as an L1 square divided by L2 square, that is equals to I1 is to I2. Yes, the ratio of their moments of inertia is given, it's an L1 square divided by L2 square, this is 1 by 4. So if this has been given, it's an L1 is to L2, which is equals to 1 is to 2. That's it, done. Have you got this? Have you have you got this? Are you sure? Are you? Great. Let's work for the last question of this session. This says that a rod of length 1.4 meter and negligible mass has two masses of this and this, 0.3 kg and 0.7 kg, tied to its two ends. Find the location of the point on this rod where the rotational energy is minimum. Very good and highly conceptual question. Where the rod is rotated about that point. Yes. So one thing is sure, that when rotational energy required is minimum, rotate it from the COM, center of mass. When and when minimum rotational energy is required, when and when minimum rotational energy is required, you need to rotate it from the center of mass of this body. Why? Because if you remember the parallel axis theorem, it's an I required, it's equals to I COM plus m into d square. So in this case, if d is equals to 0, then I required will be equals to only the I COM. And if I do this, if my I required is equals to I center of mass, if my moment of inertia required is equals to I center of mass, that means this is the minimum possible. This is the minimum possible moment of inertia for me. Yes. So what I need to do is that if I understand this, then I need to do only this. Road is there. This is having a length of 1.4 meter. It is having two masses. One at this end, it's a 0.3 kg, another is at 0.7 kg. Yes, and I need to rotate it. But before I rotate it, I need to first find out the moment center of mass of this system. So what I'm supposed to do is, it's x com would be is equals to zero point 0.7 multiplied by 1.4 divided by zero point 0.3 plus zero point 0.7, it's a 1. So it's a 7 by 10 multiplied by 14 by 10. This is 14 sevens are 98 by 100. It's a 0.98 from one end. Yes. So it's a, this is 0. This is 0.98 from one end. So from other end, let's say this x1 is 0.98. So this x2 will be equals to 1.4 minus 0.98. I hope this is clear. Yes. So it's a 1.40 and 98, it's a 0.32 meter. So now what you need to do is, you don't need to do anything, you need to find out the moment of inertia for this axis. So your rotational axis is this. You need to rotate this system from here. So it's an I is equals to m1 x1 square plus m2 x2 square. Your mass 1 would be equals to 0.3 into x1 square, this is 0.98 whole square, plus your mass 2, it's a 0.7 multiplied by, it's a 0.32 whole square. Solve this and get it done. This would be the kg, this would be the kg into meter square. I hope this is clear. Is it? Great. So let's just wind up this session over here. Yes, this is all about the rotational motion. in reality, this is the last lecture of system of particle and rotational motion. Yes, we have completed this with additional questions, but for you to do this, you need to practice hard. You need to solve so many questions. Please attempt at least 20 to 30 questions each day. This is even the completion of the very important concept or very important segment of the physics, which is the mechanics part. Yes, we have done the laws of motion, we have done the work power energy, we have done the system of particles and rotational motion. This segment contains a very higher amount of weightage in any of the competitive examinations, and this segment requires a large amount of time to get a command over it. So please revise it thoroughly. Please have a practice of it regularly. At least make a rule that each day you are going to attempt a certain number of questions. That will create a larger question bank in your mind, and that will help you guys in the examinations. I hope this is clear. Please please do as many questions as possible. Yes, because these are the concepts having very large variety of applications, because this has been connection with everyday everyday life. Yes, please do this. Thank you. Have a good day. Take care. Bye bye.